Alright folks, this video is going to be about identification of oxidation reduction reactions and identification of oxidizing reducing agents. Let's see first part. Okay, how do we know whether a reaction is an oxidation reduction reaction? Take a look at these two examples. The first one, zinc react with hydrochloric acid, generate zinc chloride and hydrogen gas. First thing you need to do is assign oxidation state. Zinc oxidation state is 0 because it's a free element. Hydrochloric acid, hydrogen positive 1, chloride negative 1. Zinc chloride, zinc positive 2, chloride negative 1. Hydrogen gas, free element, oxidation state is 0. Now when you compare the oxidation states before and after the reaction, you can see zinc has oxidation states increasing and hydrogen has oxidation states decreasing. So once the reaction involving oxidation states change, then this reaction is an oxidation reduction reaction. So yes, first reaction is an oxidation reduction reaction. Second example, hydrogen positive 1, iodine negative 1, lithium positive 1, oxygen negative 2, hydrogen positive 1. Lithium iodide, lithium positive 1, iodine negative 2, water positive 1 for hydrogen, negative 2 for oxygen. Now, when you compare oxidation states before and after reaction, no change at all. Therefore, this is not an oxidation reduction reaction. All right, second part. How do we identify oxidizing reducing agents? Let me remind you about one thing. When we talk about oxidizing reducing agent, we are talking about reactants only. All right? Oxidizing agent, let's define it. Oxidizing agent is a reactant. Okay, we're talking about the reactant. Is the reactant oxidize other reactants? Oxidize other reactants. Okay. How about the reducing agent? Of course, that's gonna be the reactant reduces the other reactants. Okay, so this is how we define them. Let's take a look at these two examples. First one, okay, in order to, both of them are oxidation reduction reaction. But in order to identify oxidizing reducing agent, you still need to identify the oxidation states for all of the elements. Iron oxide, iron is positive 3, oxide negative 2, carbon monoxide, carbon positive 2, oxygen negative 2, iron free elements, it's 0, carbon dioxide, carbon positive 4, oxygen negative 2. Okay. Now, when you compare the oxidation states before and after reaction, iron apparently is reduced because the oxidation states of iron decreases from positive 3 to 0. Okay, so iron is reduced by what? By carbon monoxide. Okay, because in carbon monoxide, carbon is oxidized. So apparently, iron is reduced by carbon monoxide. So carbon monoxide is a reducing agent. Okay, this is a reducing agent. Okay. On the other hand, because carbon in carbon monoxide is oxidized, so iron in iron oxide can oxidize carbon. So iron oxide, the whole thing, okay, is the oxidizing agent. Okay, oxidizing agent. All right, so let's make a brief summary. Oxidizing agents oxidize the other reactant. An oxidizing agent should contain the element that is reduced. Reducing agent reduce the other reactant, and the reducing agent should contain the element that is oxidized. All right, based on this, let's take a look at the second reaction. Okay, so aluminum, let me change the color. So aluminum oxidation state is 0. The copper 2 plus oxidation state is positive 2 because it's just a simple ion. Aluminum 3 plus oxidation state is positive 3. Copper 0, copper metal, 3 elements, so oxidation state is 0. Now, since aluminum is oxidized, right? So copper 2 plus has to be the oxidizing agent. Oops, I missed the I. Oxidizing agent. All right. And on the other hand, because copper is reduced, so aluminum has to be the reducing agent. Okay, so reducing agent. I hope this video can demonstrate how we identify the oxidation states, oxidation reduction reaction, and how we identify oxidizing reducing agents. Okay. Again, let me remind you again. The most important thing for you to do is identify the oxidation states for all of the elements before you do this work. All right.